what's going to happen is that there is someone called a tangent, right? So there could be a line that can come and intersect this graph, and then denominator y equals to mx plus c. And sometimes that guy, as your y, he can be called g of x. So the goal here is that we need to determine the equation of someone called a tangent. So we are given a graph of a hyperbola, as you can see. And if you see a graph of a parabola on the second quadrant and the fourth quadrant, you must know that the graph is negative and is basically decreasing. If you see the graph in the first quadrant and the third quadrant, you must know that the graph is increasing. Yes. I wanted to say hyperbola. I couldn't know not hyper. Hence, I'm killed. Yeah. So, you know me, right? But yeah. So the thing is that with your hyperbola, right? Whenever you see the graph in the first and the third, the graph is positive, the graph is increasing. If it's in the second and the fourth, the graph is definitely decreasing because it's negative. So now we are having a straight line that touches f of x, which is the main function, our hyperbola. It touches that guy at exactly one point. So what is a tangent? We say that a tangent is a straight line that touches a curve or a graph at exactly one point. Which one? A straight line that touches a curve. It could be a curve, maybe a graph like this, and then you have someone touching there. There's a point P there. You see, a straight line came and touched the curve at exactly one point. That kind of a straight line, we call it a tangent. If you date only one person, you are a tangent. Did you hear that? But if you tend to date more than one person, you're not a tangent. Even if you might look straight, but then my goal is this, my friend. A tangent is basically a straight line that touches a curve at exactly one point. Number two, if you see a straight line touching a curve or a graph more than one point, we call it a secant. We call it a secant. Which will sharp. Taba ashi. How do you determine the equation of a tangent? There are two scenarios that the examiner will definitely do regarding the tangent. One, he will give you the point at which the tangent touches the curve or the graph at. The examiner will give you the point at which the function, the straight line, which is your tangent, it touches the f of x more. So basically it means that this straight line, which is your g of x, which is your tangent, it touches this guy maybe at point A. Maybe point A, you will have working get 3 and minus 1. That's your point A. So that's when the tangent touches the f of x at. Okay, fine. Now we have the point at which the tangent touches the function. What do? We need to remember something because we're dealing with the functions, and functions are related to the cubic functions, which is a bit of calculus there. So we need to find the derivative of this guy. After finding the derivative, you are going to, where you see x, you're going to substitute the value of the x value here of your point. You will find the gradient of the tangent. The equation that the gradient the point of money equation the plus school street. First step, we need to rewrite this guy in a standard form because so you can't derive it when it's like this. You are not allowed to. If you're doing advanced maths, yes. So we need to say 3x to the power minus 1 plus 4. Basically, this is f of x, my bad. Okay, that is our step 1, right? So let's start to derive. I'm going to have positive because now I'm going to have negative times positive. Negative times negative is positive, meaning negative 1 times negative 3 x to the power minus 1 plus 0. The derivative, the derivative of a constant number is always what? 0. So I'm going to have the derivative of the guy equals to 3x minus 2. You know, 3 over x squared. You are done. That is the derivative of f of x. Since we got the derivative, my friend, we are not yet done. The first step is done. What do? We are going to substitute the point at which the tangent touches the what? The function. Why? Because that point when you substitute on the derivative is going to give us the slope, which is the gradient of the what? Of the tangent. How do you do that? You say of minus 3 was positive equals to 3 over 3 squared. Believe me, this is going to give us 3 over 9, which is the same as 1 over 3. So meaning the gradient is 1 over 3. After substituting the x value on the derivative that you have got, my dear, you are going to get this guy. The guy that you get, he's basically called the slope or the gradient of the what? The tangent. Okay, I have the gradient now. Am I done? No. Why? Because the examiner said he's looking for the equation. Okay, fine. Can I get the equation? Yes. So I'm going to say y equals to mx plus c. Where I see m, I'm going to put my gradient as 1 over 3. 1 over 3x plus c y. Okay. How do I get the point C? For me to can get point C, my friend, I have the point A, which is the point at which the tangent touches the what? The function. Okay? So it means that this guy, he's on the same straight line. He's on the same line as your tangent. So I can use him because he's part of the line. So y go be minus 1 over 3 into 3 plus c asante. From there, c I will get 1 over 3 times 3 to equal 1. Yeah, well, it can minus 2. So therefore, y equals to 1 over 3x minus 2. It is the equation of a tangent. Then it's always straight.
Can I just say something?
Yes.
I did it right like up to that point with like 3x is 2, and then I just forgot to like put the 3 over x squared. Yeah, that I forgot to do.
Remember, from the laws of exponents, your exponent must never be negative.
Right.
Write them in a positive form. I mean, yes, you are seeing a bit of light there. I think the light was a bit dim. But well done.
Thank you.
Welcome. Okay, so please always know this is the first scenario, the first case, the first situation in which they can basically ask you regarding anything with tangent. That's basically what you do. We treat this part.
Yes.
Okay. The second part